Well, welcome everyone to this academic webcast on teaching statistics in the health and life sciences. We're going to jump right in. I'm going to use these two data sets at the top for a lot of what we talk about today. So I'm going to open the first one. This is VA lung cancer. If I click in the data table, you can see a few notes on it, including where the data come from, this statistical analysis of failure time data. And there's some notes that are specific. If you use this data set from our sample data library in the help menu, you can use this as a nice example for survival analysis, and including non-parametric survival analysis. So there's oftentimes really nice resources in our help menu if you're looking for examples to use when teaching. Going to this help menu and then sample data will show you an index list of topics. So if, for example, you want to talk about mixed models, as we'll do later in this session, you can find some nice example data sets to illustrate mixed model topics and so on. So sometimes in the sample data set, you'll find specific things that we have these included in the JMP software as good examples for. I'm going to use this data set for a lot of other things today as well. So let's start by talking about how to make a table. Making tables and graphs is a very common thing that you're going to need to do if you're using JMP or any data software for analysis and producing reports and publishing those reports, things like that. So how to make a table in JMP. There's a specific menu option under the Analyze menu. There's this tabulate option. This is a drag and drop interface to create tables in JMP. So we're going to start right here with tabulate. So I just went to Analyze and Tabulate. And now I have these drop zones where I can make a table really quickly. Now I should talk about this data set for a moment so we can make some educated choices about what kind of table might be interesting here. These data include time of survival for a bunch of patients that had lung cancer. We know their cell type. We know if they were in a standard treatment or this new test treatment. We know if they'd ever had prior treatment for their lung cancer before. We know their age when entering the study. We know how long it took between being diagnosed and entering the study. And we know this KPS score, which is a quality of life score. We also know whether or not the data are exact data of time to survival or when they, how long they survived, or if it was they were still alive at the end of the study. So we don't actually know. We know they lived at least this long, but we don't know how much longer after the end of the study they lived. So we've got this extra information as well that we can include in some of our models. And then the other variables that are saved already are just response. So we've already fit some models, and we saved those model predictions back to the data table. I'll just delete these because we aren't going to use these right now. So now this is just the raw data that we get from the trial. So if I go over here to tabulate, so remember this was analyze and tabulate, I have these drop zones, and the response that I'm probably interested in is the time to survival. So I might drag time into the columns. So as I drag, blue rectangles sort of highlight around the zone where I could drop this. I don't have many options right now because I don't have much of a table created yet. So I'm going to drop the time into this drop zone for columns. And when I do, this got very tiny, and it shows me now the sum for the time in the data set. I don't really think the sum is interesting, so I might swap that out with a different statistic, like I might want to look at the mean time to survival instead, which is 121. Or maybe in addition to the mean, I'd also like to see the median. I can drag this on top of mean to replace it, or I can put it to the side, and you can see this little blue drop zone appears to the side of mean, and now I can add the median as well. Maybe I'll also look at the minimum, and I'll drag that on the other side of mean. Maybe I want to see the maximum. I'll drag that on the other side of median. So now I see sort of some summary features of a distribution of time. I can see that the minimum time to survival was 1, the maximum was 999. This actually might be a flag that this could be incorrect data. Perhaps this is a missing value code, but I'm going to treat it like it's real data right now. The mean was 121, the median was only 80, so I can see some evidence of skewness here in these data. And now I might want to make my table a little more interesting and split out the time into different groups. So if I wanted to group this by cell type, for example, I can drag cell type. I don't see the drop zones now, but if I hover, I'll see drop zones appear. So I can drag cell type over to the rows and drop that in. And so now I see this split out by the 4 different cell types. I can see, maybe I'm also interested in how many patients were in each of these groups. So I'm going to drag the number n in as well and put that right before the minimum. That's helpful information to me to sort of understand this distribution happened for 27 people in the adeno cell type group, 27 people in the large cell type, 48 in the small. As I'm clicking through, you can see in the background my data table is highlighted when I click on the 27 large cell type patients. That's because everything in JMP is connected. And when I click on some data in one thing that I have open, it's going to highlight everything else that I have open that associates with that data table, including the data in the data table. So I can see as I click through that the 27 adeno patients get highlighted. Now the 27 large cell type patients get highlighted. I can add more information to this table also, sort of a nested structure on the columns if I want. So I might also group the cell types by the treatment, whether they were in the test treatment or the standard treatment. So I could drag this in front of cell type, and then I have the standard and then split out by cell time and the test split out by cell type, or I could switch that, put it in the other order by dragging it on the other side of cell type. Now I have cell type first and then the treatment. Actually, I think I preferred it the other way, so I'm going to drag treatment back onto this side of cell type. And I can even put yet another layer to this. Maybe I'll put the prior treatment or not in front of the standard and test treatment. And then in addition, maybe I don't just want to look at the time to survival. Maybe I also want to look at the distribution of age or the distribution of KPS or the distribution of diagnosis time, time from diagnosis to entry into the study. So let me drag diagnosis time. I'm going to just hover it so that it highlights all of the data that I've got so far. And now that's going to duplicate when I let go. So I have all that information for time and then all that information for diagnosis time. And when I'm happy with my table, I can click Done. And I can save this out in a lot of ways. From the File menu, I can export this if I'm using JMP on a Mac, or on Windows, I can click Save As and save this in a number of different file types. So I could save it as an image file type, for example, or I could save it out into a PowerPoint slide as an editable feature. I could save it out as text. And now I'll show you in Graph Builder how we can make a graphic visualization of a very similar thing. So we're going to now switch into a different platform. So this was making a table using Analyze and Tabulate. We have a similar drag and drop feature in the Graph menu called Graph Builder. So I'll click on Graph Builder, and we can now visualize these same data in a graphic sort of format. So I'm going to look at time as my response again. I can drag into these different zones. So I'll grab time, and as I drag it around before I let go, I can see different drop zones highlighted again and different things that will happen if I drop in different places. I'll drop this in Y. So now I see a distribution of the time. On this ribbon along the top, I can see that these little points, and if I hover over it, it says points and then shows a scatter plot of data values. This has a slight shading to it, which is indicating that I have the points displayed right now. If I want to add other features, I can drag them down on top of this, which we'll do in a moment. I also see for those points that I get extra information or extra things I could do. For example, I could unjitter them. That's not as attractive, so I'll click back on jitter. I could add a summary statistic instead. So right now it's showing me the raw points, but I could just look at the mean value instead. Again, that's not quite as meaningful, so I'll go back to no summary statistic. Let's add on some more variables now. So I might want to split the time out like I did for this table by cell type. So I'll grab cell type and I'll drag that down to the x-axis. So now I see those points jittered for each of the 4 groups, sort of spread out so I can see where they are. I can hover on a point to see what that time was. So this was the 999, which was the highest value in the data set. This one next to it is 991. So that indicates to me that possibly that 999 is a legitimate value and not a missing value data code that got read into the data. So I think that that's a real value, that 999. The highest in this group is this 553. You'll notice when I hover, I have the option, if I scroll to the side, I have this pin. I can always pin a callout box. so that that's actually part of my plot now. And if I save this out, that will be saved. If I want to change the information that gets displayed there, I just need to go back to the data table. In the data table on this side panel that says columns, anything that I right click and click this label for, it will show up with this little yellow label icon. This indicates that that information will always be displayed whenever I hover over a point. So if I wanted extra information, maybe the time to be displayed, the cell type to be displayed, I could change these, right click on them and ask them to be label features. Now there's a little label symbol. So now when I go back to that graph builder, I'm gonna unpin this and I'll pin it again. Now I see that the cell type is listed and the treatment is listed because those were the two label features. The time is also listed because that is the response that the value I've got in this plot right now. Okay, so we could add some other features. I could connect the means, for example, in these stacks of data. Now I have a new piece of information for that line that I've applied. So I have information for the points and I have information for the line. Maybe I want for the line to include a standard error bar. So the distance it goes from the mean is one standard error, or instead I could do a standard deviation, which is farther because standard error is the standard deviation divided by the square root of the sample size. Or I could put a confidence interval for the mean. So I'm going to choose, or I could put the range. It will show me the entire range of the data. I'm going to choose the standard error. And maybe instead of having a line that connects them, I'd prefer bars to show where the mean is. In this case, again, I have the option to add a standard error or one of those other ways of looking at this. Maybe instead of bars, I'd like box plots. So I'll click the bars off and I'll put box plots on instead. Maybe I want the box plots and I want to connect the means to just make it really visually obvious for me. Or maybe I'll go back to just connecting the means and putting a standard error on this. I can also split this out by more things than just cell type, just like I did in the tabulate. I can add layers to this. So let's add a layer for treatment. I'll grab treatment over here, and I'm going to still try to drag it down to the X, but you'll see more drop zones appear. So if I drag it to the top drop zone on the X, this is going to nest it inside of the cell type. If I drag it sort of in the middle, it'll replace cell type. If I drag it to the bottom, it will be an outside classifier. So I now have the treatment, standard on this side, test on this side, and then I have the cell types nested inside of those treatments. I can do this again with the prior. So I'll drag it to the very outside. So now I have a nesting, a 3-layered nesting. I have no prior, then standard and test nested within that, and then the 4 cell types nested within that. And then on the other side, when I have, yes, they did have prior treatment. And when I'm happy with my plot, if this is the plot that I want to use in a report, I can click done. And again, I can save this out in a lot of ways. I can use export on my Mac, so file export, or on Windows, I can use file save as and save this in a lot of different ways. I can also always right click on things or double click on things to find more options. So if I want to change how the tick marks look, if I want to put a reference line in the middle of my plot, or even put a range, a reference line that has a whole bar, a range of reference line for the reference line, I can find these options by double clicking on the axis or by right clicking. I find more axis settings and so on. So there's a lot of ways to customize your plot. If you have certain font sizes or font families that you want to always use for your plots or use very often, you can also go to the File and Preferences on the Windows, or on Mac, it's Jump and Preferences. And you can find preferences to change. For example, I can change the fonts and I can apply my changes, and then those are going to remain every time I open Jump. It's going to use my preferences. So you can easily customize things. I can click in titles to change the title instead of time and mean time versus prior and 2 more. Maybe I want to just call this time versus prior and treatment and cell type. So it's very easy to customize what you're doing with Graph Builder. Another cool thing that I can do this from any platform in JMP. I use the red triangle to find more drill down options, and this local data filter will always be available from any analysis or any graph. The local data filter lets me filter on something so I can customize my plot to look only at a subset of my data. So I might want to filter on cell type, for example. So I'm going to keep this plot, but I'm only going to look at the plot for the adeno cell type, for example. So here's the adeno in the standard and no prior, adeno in the test and no prior, adeno in the standard with a prior, and adeno in the test with a prior. Or maybe I want to look at everything except for squamous. So I can highlight all three of these options and only exclude the squamous. So if I want to customize my plots by filtering out and only looking at certain things, I can do that really easily by applying a local data filter. I'll show you how to do that on Tabulate as well. Again, the red triangle, local data filter, and let's do it this time. Well, we'll still do it on cell type. So I'll add this same filter. Here's just looking at that table for the adeno. Here's looking at that table for large, for small, or again, I can choose multiple groups at the same time. I can add other filters in addition. So I could say, and I also want to filter this only on those patients that had a KPS score of at least 50. So I can use the slider or I can enter values right here. Okay, so we looked at a number of ways to create tables, to create graphics. Let's also look at making geographic maps. For the geographic maps, I'm going to close this data set and open this obesity data set because this data set has a geographic element to it. These data came from, they're the US Census from the year 2000, county level reported data. They come from the Center for Disease Control, the CDC, and we have a row for each county, each unique county. So we have these divided up by state, then by county. We have the county FIPS code. We have some variables on the percent of the county that has diabetes or estimated to have diabetes, estimated percent that are obese, the poverty rate for that county, the total population of that county, and then we have latitude and longitude. So to create a geographic map, I again go to Graph and Graph Builder. And I have two ways to make a map. One is if I have latitude and longitude or GPS coordinates, I can just drag these right into the middle. You can sort of see the points are very thick. And you'll notice that first there was only one point highlighted, and then I clicked off the plot to highlight everything. That's because I had only one row selected before. And then it shows me that one selected row. But if I click off of it, it'll highlight all the points again. It also has this blue line showing up, which is the smoother because right now it's just treating latitude and longitude as a y and an x variable. So if I don't want that smooth line, I just click on it to take it off of the plot. And I might right click in the back of this and go to to graph and background map and ask to put a simple earth or a detailed earth map in the background to show me these data. And now I could do things like color those points by the percent diabetes and so on. But an easier way, I'm going to click Start Over. An easier way when I have a map shape that JMP can recognize, for example, state or the county FIPS code or zip codes or country names, any of those four variables, country names, state names, county FIPS codes, or zip codes, are something that JMP can recognize the shape of. So if I take state, for example, and drag it into map shape, JMP recognizes the names of the states within the column and it can create the map shape for me. So then I could look at, for example, the estimated percent diabetes. I could color these by the percent diabetes in each state. But think about what's happening for a second. So each state is made up of all of its counties, and each county has the percent diabetes. So right now I'm averaging an unweighted average of the percent diabetes where each county gets an equal representation. If I want to weight this by the population in the county instead, I could take the total population and drag this into frequency, and now the weighting is going to be weighted by the population. So now I have averages of the counties that are weighted by the population in that county. Another thing I can do if I want to look at this county by county instead of state by state, I'll click Start Over. And instead of dragging state into the map shape, I'll take the county FIPS code instead. So here I have the counties, and it looks like there were 3 county FIPS codes that were not recognized. This can happen if you've got something miscoded. It can also happen if county FIPS codes have been updated since the last release of JMP. We're as up to date as we can be, but if there's been an update since the last release of JMP, this could happen. So you can go in and make these changes. So it will give you a clue if there's a problem with any of your counties. So in this case of our 3,140 counties, there were 3 that it didn't identify. And now I can drag things like the estimated percent diabetes on top of this map. And so now each county is individually colored by its data value for the percent diabetes in that county. I could click Done. I could again apply a local data filter if I want to filter this just by state, for example. So I could look at just the counties in Florida, for example, or just the counties in California. Or I could pick Florida and Georgia together. And you'll notice that it rescales the color based on my local data filter because it's recreating this map only for the data that I want to include. Another thing I could do instead of the data filter is I could use the red triangle and I could ask for this redo column switcher, and I can swap out the percent diabetes. I want to keep the county FIPS codes because I want to keep that map, but I'll swap out the percent diabetes and I'll instead look at the percent obesity, the poverty rate, the total population. Well, in fact, I'll still include the percent diabetes. And now I can flip through and see this map really quickly on all of these variables. I could also hit the play button and let it flip through for me. And again, when you're happy with something, it's really easy to save it out by going to the File menu and either Save As or Export. Save As if you're on Windows, Export if you're on Mac. Okay, so we talked about making tables from Tabulate, making graphs and geographic maps from Graph Builder. So Analyze Tabulate is how you get to tables. Graph and Graph Builder is how you get to this flexible drag and drop Graph Builder platform. Now let's talk about how to do ANOVA and regression, which are very common analysis types in the life sciences. So from the Analyze menu, and I'm going to open the lung cancer data again, and I'm going to delete these columns. From the Analyze menu, FitY by X is a flexible platform that lets me do a number of different types of analyses depending on the variable types I have. This little blue triangle icon indicates continuous data, and the red bars or green bars indicate categorical data. The red bars indicate nominal in name only categories, not ordered. The green bars indicate ordered or ordinal categories. We can see them over here in the columns side again. So if I click on this, I can change this coding if I want to. So if I go to the Analyze and Fit Y by X, I can get any of these types of analysis out of this platform. So I could drag time of survival into Y, and I could drag cell type into X. Here I'm in this situation, a continuous Y and a categorical X, which is going to give me a one-way ANOVA sort of analysis. Another option would be to use the KPS score as my factor instead. Whoops, put that in the wrong place. So instead of cell type, now I would be in a regression sort of situation. Or I could use a categorical response with a continuous predictor and get a logistic regression, or with a categorical predictor and get a contingency chi-squared type of analysis. So I can get any of these from the Fit Y by X platform, but I can only use one X and one Y at a time in Fit Y by X. So Fit Y by X is designed to just be one X and one Y. When I have a more complicated model with multiple X's or multiple Y's, or I want to use extra features that aren't available in the Fit Y by X platform, I'm going to go to Fit Model. So I'm just going to start us in Fit Model. There's a lot of cool teaching features in Fit Y by X if you're teaching one-way ANOVA or you're teaching a simple linear regression. But once you get into more complicated models, Fit Model is a more flexible platform. So I'm going to click Fit Model. You'll see that it already populated the model. This is because of a feature in this specific data set. So I'm just going to delete these things so that we can start from scratch. So generally, when you first open Fit Model, you're going to see blank boxes, and you're going to click your variables into the right spots in this box. So this is where we put our response up here at the top. And this is where we put our model effects, our X's. So I want time to be my response. And I might want a model that includes cell type, treatment, the prior, the age from or the age of the person at the time of diagnosis, the age at the time of beginning the trial, the diagnosis time from diagnosis to beginning in the trial, the KPS, which is that quality of life score. So I might choose a model that has all of these variables. I can click multiple things at the same time and click Add to put them into this box. I can also use this macros if I selected some things and I wanted, for example, to do a full factorial of those or factorial up to a certain degree. The degree is hiding right here. I can change that number if I want to. I can also apply attributes. If one of these variables was random, for example, I can make it a random effect by clicking on attributes, or if I've got spline effects and so on, I could transform a variable here, or I can also transform a variable by right-clicking it over here and asking to transform it. In this case, I think I'm just going to use a model with only the main effects. And if I just want to fit a standard least squares, typical regression, or ANOVA type analysis, I would choose the personality standard least squares. We're also going to look at generalized regression today. We'll look at mixed model, and we'll even look at proportional hazard and parametric survival today. But let's start with standard least squares. This is a pretty standard typical model, a typical regression or a typical ANOVA. So I'll click Run. In this case, we might call the model that we're creating an ANCOVA because it's got both categorical and continuous predictors. That's one way we could talk about this model. And I see a lot of plots. JMP is designed to try to give you visuals everywhere that we can. We want you to look at your data and really see what's happening in your data. So I can see that this is not a great model because my variance is fanning out. There seems to be some kind of trend that wasn't captured by the model. So I can right away see that I probably want to keep working on this model and improve my model. I can see the summary of fit. So here's my R squared. Here's my ANOVA table and my overall ANOVA p-value that says, yes, at least something from that set of X's is statistically significant. I can see the parameter estimates for the effects. Remember, there are 4 cell types. So I can see here that it's comparing everything to the squamous cell type, which was the last cell type. So it compared everything to the last one. If I want to change which group is the comparison group, I can go back to the data table and I can click on cell type and I can add a column property. So I double-clicked cell type and I can always add this value ordering. Right now, squamous is the 4th group. That's the one I'm going to compare to. If I want to change the comparison group to something else, I just need to change the order. So if I wanted my comparison group to be the large tumors instead, I could move the large down to the last group. That's going to now be my comparison group in that platform. I can also see the effect tests for just the p-values for the overall effects in my model. And from the red triangle, I get lots of other options. For example, the factor profiling gives me the profiler. This is a really helpful tool for really visually understanding your model. I'm going to make these a little bit bigger. So what we have here is this is telling us the predicted time of survival based on different combinations of our factors. So different settings of our factors. So here for the adeno cell type, for the standard treatment, for no prior, for a person who's 58.307 years of age that was enrolled 8.774, I think this is months after diagnosis, and with a quality of life score of 58.569 on that KPS scale, that person has an estimated time of survival of 46.47 months, with a confidence interval for that mean prediction from -18 to 111. So that's not actually a very nice model. Our confidence intervals are very wide. We might explore if there are certain regions that have better confidence or worse confidence, perhaps different cell types. So it looks like the small tumor is a tighter confidence interval. So this one, this particular combination of factor settings, small cell type, standard treatment, no prior, age 58.9, diagnosis time 8.774, and KPS of about 60. The estimated time of survival here is 73.45 with a confidence interval on that mean prediction of 27 to 119. So this is how we would get a regression model or an ANOVA model. The prediction profiler is really helpful. I can also look at the interaction profiler here. We didn't put any interaction terms in our model, so all of our interactions look like the lines look parallel because we didn't allow interaction terms in this model. But if we had, we would see the effect here. And from the top red triangle, we can see things like row diagnostics. I can plot the studentized residuals, look at the press statistics. I can save things back to my data table, like the HATS or the Cook's D. I could save back the prediction formula to my data table, standard errors for the prediction formula, confidence limits. So there's a lot of things I find in the red triangles that are advanced options. Let's look now at mixed models, which we're also going to get from that fit model platform. So I'm going to minimize these data sets right now. And we'll move into mixed models. We'll still come back and talk a little bit more about some regression and ANOVA output as we're talking about mixed models as well. So I'm going to use another data set, this machine data set, to show you mixed models. This data set, if I click in the notes, this is an unbalanced data set that has random effects. In this case, we have several machines. It looks like we have 3 machines and maybe 6 different people, and then each person is looking at each machine and making a rating. I might use the distribution platform to get a sense of the unbalance in my design first. So the distribution platform is just a way of looking very quickly at the distributions of all my variables or some of my variables. So I'll just click all of my variables into Y and say OK. So I can see a distribution of the response, the rating. I can see that the average rating is just about 60. There's a confidence interval on that rating. I can use the red triangle to customize the summary statistics if I want to look at different things, like I want the variance or the skewness or kurtosis, the trimmed mean, an interquartile range. I can ask for whatever I want. I can also use the red triangle to do things like test a mean. So if you just want to test the mean of one variable, so get a hypothesis test of one mean, you would do that here. You'd also use that analyze distribution like we just did with a categorical variable if you wanted to test the probability. So here for these categorical variables, I can test probabilities. So if I have a test of 1 probability or a test of 2 probabilities or a chi-squared test of many probabilities, I can get that here. It just depends on the type of variable that I entered into this platform, whether I get something categorical with probabilities as a response, or if I get something continuous with summary statistics like the mean as the output. I can also, when I click on something, again, everything is connected in JMP. So I can see that when I click on machine 1, it highlights machine 1 back in the data table and also in everything else that's open. So I can see that machine 1 was rated by all the people, but I can see that it was rated more times by person 6 than it was by person 1. So I can see some of the unbalance already. If I click on machine 2, again, I can see person 1 only rated it once, person 2 seems to have rated it 3 times. And if I click on machine 3, I can see that's the only machine that was balanced across person. I can also see that machine 3 had high ratings. Machine 2 had maybe some low ratings and sort of middle ratings, and machine 1 has lower ratings. So it looks like machine 1 has the lowest ratings, 2 middle, and 3 high. So I can already kind of explore my data and get some ideas from this distribution platform. Now if I want to run a model, I'll go to Fit Model, and I might, so I'll pull rating into the Y as the response, and it automatically gives me that standard least squares as my personality. So it's going to fit a typical regression or a typical ANOVA. The model I want to fit is going to have machine as an effect, person as an effect, and the machine by person interaction as an effect. So I can add things to this construct model effect one at a time. So I could add machine, then add person, then I could click on machine here and person here and cross to get that interaction in. That's one way to put my model effects into here. Another way is to click machine and person, go to macros and full factorial, and that builds it all at once. So when you have a lot of X variables, those macros are really helpful. If I had a nested effect, like if person was nested in machine, I could click person here because that's what's nested. Machine is what it's nested in, and click nest. And now it will have person nested within machine. Let me put my full factorial again without a nesting, because there is no nesting in this case. If I want to add random effects, I can do that from that standard least squares personality by using the attributes. So in this case, the machine is of interest. I care about how the machines are performing. I care about machine 1, whether it's better or worse than machine 2, whether that's better or worse than machine 3. So that's a fixed effect. I care about the fixed levels of machine. In this example, person could be a random effect because in fact I don't care about the specific people who are rating the machines. I just care about the overall effect. I'm really interested in the machine performance, not how good the people are at rating. That's not what this experiment is about. So the person, I sort of randomly selected people to rate my machines. So person is a random effect. I'm assuming that the specific people who rated the machines are a random sample of possible people. So machine is going to be fixed. Person is going to be a random effect. So I can I can click on person and click on the attributes and click random effect. It now says person and random. That indicates it's now going to treat this as a random effect. And it now gave me this method option. Restricted maximum likelihood is the recommended method. I could use the expected mean square method. And I might use that if I'm teaching this to show the differences. In an unbalanced design, there will be differences in the output between the expected mean square and the restricted maximum likelihood methods. So I could use this as a teaching tool, but the best method to do this analysis is going to be the REML method. I can also click or unclick to allow unbounded variance components. If I only want the estimates for the variance components, I can click that option. And there's an unfinished business here. So machine was going to be a fixed effect. If I treat person as random, then I need to treat machine by person as random as well, because randomness in a mixed model is sort of like a disease. So if a term is random, everything else that touches that term is also random. So if person is random, that means person by machine is also going to be random. So I'll also go to attributes here and add this one as a random effect. So this is one way to set up a mixed model in JMP. I can use that standard least squares personality, I can use the restricted maximum likelihood method, and I can add random effects by clicking on the term and using the attributes. Here I'll click run, and we'll see some general output. I can open some of these effects to see it's only going to list the fixed effects, not person or person by machine, because those were random. So it's going to show me the general, how important the machine effect was, and here's its p-value. I see this r squared for this model is really high. I can see parameter estimates for the machine 1 and machine 2 versus machine 3. So the effect of being machine 1 instead of machine 3 is a negative estimate. The effect of being machine 2 instead of machine 3 is almost 0 and also non-significant, whereas machine 1 versus machine 3 is significant. Again, if I want to change the comparison group, instead of being machine 3, I'd go back to the data table, double click on machine, and I would add a value ordering. And instead of having 3 as the last group, I would switch to the one I want as the comparison group. Now I also see the random effect predictions here. So these are the BLUPs for those random effects, the best linear unbiased predictors. I can see here's the restricted maximum likelihood variance components estimate. So here's the variance component for person and machine by person, my 2 random effects. I can see p-values on how significant those effects are. I can see some notes having to do with the fact that I allowed negative variance estimates. I can see things about the fixed effect tests and click on the effect details to get a least squares means table. So here's the least squares means and standard errors. I can use the red triangle here to get lots of other stuff. Like if I want to look at a plot of the least squares means, I could do that in Graph and Graph Builder, or I can get it directly here. If I wanted to look at contrasts or do a Tukey on a significant difference comparison of all those means, I can get that output here. So here's, for example, the letters output where it tells me levels not connected by the same letter are significantly different. So 2 and 3 are not significantly different, but 1 and 2 and 1 and 3 are significantly different. I can also see that from the other ways of looking at the output. If I have something that's a interaction effect, I can also look at slices. I can test slices. So there's a lot of follow-up output from those red triangles. Again, I could look at the profiler. Machine was the only fixed effect, so the profiler is just showing us the 3 different machines. And so there's a lot we can get here. So that's one way of fitting a mixed model. A second way of fitting a mixed model from fit model is to go to analyze fit model, populate Y is the rating again. I want machine as my, well, I'll put the terms in a second. So I'm going to change the personality now. So we actually have an entire platform for mixed models. I'll click that platform and now you see tabs for the model effects. So I put the fixed effects in this box, the random effects in this box, and if I have a repeated measures situation where I want to put a different covariance or correlation structure, I can choose from these structures. So here I have machine as my fixed effect. My random effects were person and person crossed with machine. If I wanted to have a random coefficients model or nest random coefficients, I can choose different options here. And here I'm just going to click run. So again, I get the variance components for the person, person by machine, and the residual. I get the fixed effects estimates for machine 1 versus 3, 2 versus 3. I get the BLUPs, those random coefficients. I get a fixed effect test, and I use the red triangle to get more options, like to do multiple comparisons. Here, my multiple comparisons are least squares means for an effect, where I can choose, for example, to do the Tukey on a significant difference and compare all of them. Or if I want to specify specific effects I care about, I can use user-defined estimates. So the red triangle is where you find all the options. Again, I can save things back to the data table like the prediction formula or the residuals. I can do marginal model inference and look at the profiler for the marginal model. Or I can do conditional model inference. I could look at the profiler for the conditional model. And so on. So there's 2 main ways to get mixed effects models, both of them from fit model. One of them is using the standard least squares personality and just using this attributes to make things random. The other one is using the mixed model personality, putting fixed effects in this box, random effects in this box, and you can also treat repeated measures looking at the correlation or covariance structure here. Okay, let's talk a little bit about multivariate methods and clustering. I'm going to close this machine. And let's look at the obesity data again. We'll pull up, let's see, I think this is a, so I quickly clicked on this script. When you do something in JMP, like build something, if you go to the top red triangle to save script to data table, It will prompt you to give it a name. You can say okay, and then it makes this little play button in your data table so that the next time you open it, you can just click that play button and it will repeat the analysis. So that's really helpful if you want to quickly get back to what you were doing before. So again, you just go to the top red triangle, save script to data table, and then you get these play buttons saved. So I just clicked on one of those in order to open up this map really quickly. So here, I'm going to take the color off of this map right now. Whoops. And bring this to the side so that as we cluster, we can actually visually see which counties are clustering together. So for multivariate and for clustering, we're going to go a little farther below fit model in the analyze menu. We'll go to multivariate methods and multivariate. This is where we have principal components analysis, discriminant analysis, factor analysis. So from multivariate, I'm going to choose these features. So each county has a percent diabetes, percent obesity, a poverty rate, and the total population for that county. So I'm going to cluster the variables or the counties based on how similar they are in those 4 dimensions. So first we're going to just look at correlations. So I'm putting these 4 variables in for Y. I'm saying okay. And so here I see the correlations at the top. There's a color coding that shows the closer they are to 1, the darker blue. The closer they are to -1, the redder they get. And things that are pretty close to 0 are pretty close to gray. Then there's a visual of that in the scatter plot matrix. I can add lots of features to that, including I could actually put the linear regressions for those pairs right into the scatter plot. I could put, I could show the correlation in the plot. So here's the R. I could show a histogram. Here's a horizontal version of that, or I could do this vertically instead. I could add the counts on top of the histogram. It's getting kind of busy, so maybe I don't want to do that. I could add, I could change the ellipse. Instead of being a 95% or confidence ellipse, I could change it to a different value. I could put a non-parametric density on top of this so that you can see where the bulk of the data fall. I can grab the corner of anything in JMP to resize it. And again, when I'm happy with something, I can always export it. Another way I can save things out is this fat plus sign. I can always select, it's a selector tool, and I can actually just copy and paste something out. I could also use the red triangle, save script to data table to save this. I'll call this multivariate correlations. Say OK, and now back in the data table, I have this new script button for multivariate correlations. If I close this and click the button, it will repeat everything I just did. From the red triangle at the top, I can look at things like non-parametric correlations. So there's always non-parametric options available wherever the parametric options are. So in this case, I could look at the Spearman's rho or Kendall's tau. I could look at an ellipsoid 3D plot. There's other ways of visualizing these data. I could do the principal components analysis right here. I could look at the Mahalanobis distance to see which outliers I have as far as these dimensions. So I might see, for example, I can see, so this is population by percent diabetes. And I can see that Los Angeles County, definitely an outlier on population. Cook County, so that's Chicago, that's an outlier on population. Harris County, Texas, Maricopa County in Arizona, Orange County, California. So these are all high population. So they seem to be really influencing the relationship here. And I can see that here in the Mahalanobis distance. If I click on this one, that's Los Angeles County. Here's Cook County. And if I make this a little bit bigger, I can see there's a dotted blue line here. That's the cutoff saying everything above that line is an outlier. So I can kind of, whoops, make a square around all of those points to see these are the high outliers in the Mahalanobis distance. I could use the red triangle and save that back to the data table. So there's a lot of things I can do to explore the data here. I might then move on to doing some clustering on those 4 dimensions. So I might choose hierarchical cluster and try to cluster on the percent diabetes, obesity, poverty rate, and total population. So here's the cluster. I'm going to color the clusters. So we can see in the map, it updates right away with the colored clusters. Right now we've got 21 clusters, which maybe is too many. That doesn't seem like it's telling me very much. So maybe I'll try to scroll and see if I see a pattern. Maybe here's a nice number of clusters. So I might choose, I'm going to click off of this to highlight all the data again. So right now I have 3 clusters. I can see that some of these counties turned blue. Most of the map is just red and green. So when I have 3 clusters, I just see sort of larger population maybe jumping out. I can also use not only color clusters here, I can use mark clusters to save the clusters back in the data table, or save clusters to save the clusters back in the data table. Mark clusters will use a different plotting character. I can choose number of clusters if I want to specifically enter the number. So let's enter 5 instead of just using the slider. So here's what I get if I have 5 clusters. And so clustering the data and then using that in conjunction with a visual is a nice way of really seeing how those counties are clustering together. Okay, so we're kind of taking a tour of a lot of different features in JMP. We're going to move on now to survival analysis. We'll look at 2 kinds of survival analysis. We'll look at parametric and proportional hazards. I'm going to use that lung cancer data again. So back to the FIT model platform. Again, it pre-populated with this parametric survival option. So I'm going to clear everything back out and show us the original output or the original screen would have looked like this. I can put time as my response. I can put all of these variables in as model effects. And then I could change the personality to, for example, proportional hazards. Proportional hazards then lets me enter the censor in this box so that I can include the fact that I don't actually know the final survival for some of the patients. The patients that were still alive at the end of the study, I only know they were definitely alive at this time, but I'm not sure when their survival status changes. And then I can enter the center code here and click run. I see the plot of the baseline survival. I can look at that as a table. So at various times, the proportion that have survived to that time. I can look at the likelihood ratio tests. I can ask for things like the risk ratios. I can see that the KPS was very important in this model. The cell type was very important. I can use the false discovery rate to adjust those p-values instead, or the cutoff of those p-values. I can look at the iteration history to make sure that this did converge, and it did. In this case, it would give me a warning if it didn't. I can look at the whole model overall p-value, and so on. If we fit this model instead of proportional hazards as a Cox or as a parametric survival, I'll go back to fit model, and let's make this parametric survival. So we just looked at proportional hazards. Let's look at parametric survival. Same model. The time to event is time. Here are the main effects we're interested in. We're not putting in any scale effects in this particular model. We can choose from the distribution for the survival model. We'll use the Weibull right now, and I can click. I could choose to look at all distributions. In fact, let's choose all distributions, and I'll click run. So this shows us an overlay of all of the distributions to help me choose which fit is best. Again, I can see the effect summary, the parameter estimates. From the red triangle, I have other options like saving out confidence intervals, looking at the residual plot. I can estimate the survival probability and save that back to the data table. If I use, let's look at the Weibull. Maybe we'll save these survival probabilities or estimate these survival probabilities for different combinations. So this is predicting at different factor settings and so on. So we won't spend much more time here because we're almost to the end of the hour. If you want more information on any of these particular analyses types, if you go to the Help menu, JMP's documentation is under Books. So if you wanted to know more about survival methods, if you click on the reliability and survival methods, you'll see a lot of worked through examples that will show you how to interpret the output and where different options are in the reliability and survival methods. Fitting linear models will tell you a lot about that fit model platform and options in the fit model platform. Multivariate methods will tell you a lot about that multivariate platform, principal components analysis, factor analysis, discriminant analysis, clustering, and so on. So that under the help menu under books is where you can find lots more examples to go into more detail about a lot of these features. Okay, let's talk very briefly about the generalized regression options, again, from fit model. This is a different personality. Generalized regression allows you both to include a censored variable. So you could make if you remember, we earlier looked at the regression on time, but we didn't have the option to include that censor information. So generalized regression allows us to include censored information. It also allows us to change the distribution of the response or the distribution of the error. So if I had a Poisson distribution instead, I could choose that here, or even a zero inflated model where I have lots of zeros and then sort of another distribution on top of that. So these ZI are zero inflated models. And so I would just choose the generalized regression platform to find those options to include censoring or to change the distribution. And then we should talk very briefly about the design of experiments platform. The design of experiments platform allows you to do things like create a full factorial design or a mixture design, or design something custom, augment a design you already have. I'll just show you very quickly if we try to design a full factorial. It gives me a place to change the name of the response. So maybe this is yield. If I want to maximize the yield, I just keep that goal as maximize. If instead I wanted to match a target, like try to get the yield to be between 100 and 120, I can add this upper and lower limit. I'm going to delete those and we'll just do this as maximize. Well, it's going to ignore them if I choose maximize. So then I could add a 2-level categorical factor. I'll just call it X1, that's fine. I'll call it L1 and L2 as the 2 levels. I'll add a 3-level categorical as well. And I'll click continue. I'm going to make a random order of these. I could maybe replicate this with one set of replicates so that I actually have 2 runs for each combination. I might choose this simulate responses from the red triangle to give me lots of flexibility, and then I'll click make table. Simulate responses lets me change what I believe the effect of these different factor combinations will be, and it gives me a column in the data table to do these simulations. So there's a lot of flexibility to do built-in simulations. When I design something using the DOE, it also gives me play buttons to get back to the model that I just built. This is the full factorial of my factors. So if I click on the model, let's look at the maybe the parameter estimates output. If I right click on this and choose simulate, for example, or bootstrap, I can actually do a bootstrap analysis of my parameter estimates, the power that I have to detect them, or a simulation. If I click on simulate, I can swap out the yield with the simulated yield. I can do this 100 times. Click OK, and it's actually going to do a simulation. I'll click on that really quickly. And it even gives me a power analysis to look at the power I had to detect those different effects. It gives me the simulated power over here, empirical p-values. So you can really quickly do some pretty complicated things in JMP. I just spent about 1 minute getting a simulation on a designed experiment, a full factorial experiment. And then one last thing I just want to draw your attention to is some tools for data preparation. We talked about a lot of modeling options, but there's also often a need to change things in your data before you're really doing the analysis. So under tables, you'll see options to sort your table or stack, split it out by a variable, transpose. Rows and columns gives you more options for the rows and the columns. If I click on a column, so if I go back to the data table, this data table, for example, and I click on columns and recode, right now I have cell type selected. If I want to combine two things, like I want to call adeno and large both adeno, you'll see that I can combine them and then save that in place or in a new column. So there's a lot of tools like this as well. Okay, so we've reached the end of the hour. I'd love to take any questions that you had, or certainly send me an email if there's anything I can ever help you with. My email address is